Alright, starting with this video, I'm gonna try out a new format. The idea is that I don't do any status updates in the end, but I do small looks into what I'm doing over the day. So let me know if that works or if I am missing anything, if I can improve something. And yeah, let's start with the first one. Alright, last time we were looking at this action right here. We were changing the ambient light in a world. And to do that in a spigot or bucket, we need to move all the players out of the world. Then we can reload the whole world. And after that, we want to move all of the players back so we don't annoy them with being at the wrong location. So this is a lot of stuff that's happening, and instead of having that inside of this change ambient light action, we can simply extract all of this into its own action, and we will name that then simply reload action or reload world action. And all that does is simply reload a world, nothing else. So this action does not know that anything else is happening, right? It just unloads the world, reloads the world, moves the players back. That's it. But this allows us to make this action here much nicer to read. And if we implement that and remove all of that code, and we will simply say that we have we call the world facade and we call the reload action here, and we wait for that to finish, and then we can print an output. And now our action suddenly becomes very easy to read, right? We get a world, we set the ambient light, and then we reload the world and we give feedback about that. And this now becomes so easy to read because we were able to extract all of this heavy lifting into another action. And now if we need to reload a world in another action, for example in our new change special light action config, where we pretty much do exactly the same, we can now copy the exact same code here to that new action, and we can also replace all of this reloading code there. So this can get much cleaner by a simple task like this. And this is how it looks in action. We are in a world, we can change the ambient light, we get quickly teleported out and back in, and you can see it gets darker, or even brighter. Pretty easy. With Minecraft, I think 1.14 or 15, it changed how exactly ticks are being calculated. And this results in my system inserting way too much in a short period of time. So if I have this selection right here and I insert something, then you can see that this area is being inserted extremely quickly. It's now already finished. In 3 seconds, it inserted like 400, 500 chunks. And this is definitely too quick, right? We can see here in my short stack trace that we are going up to, what is this, 250 inserts per tick. This is way too high. I am setting this to only take 10 milliseconds of each tick, so this should maybe result in a value of 30 or 20. So I need to find a new way of managing time with a new system so this does not get laggy. So I'm gonna test a new approach for that. The idea here is very simple. I am listening to the server ticking inside of Minecraft directly. So this is not my code, this is directly in Minecraft. And I'm simply gonna say it should create a new event if it's somewhat laggy, right? This is not the greatest code, but I'm just trying to understand how exactly this works, how exactly I can handle it the best. And if I have a good idea of that, then I'm gonna think about what system can I build that actually reflects this in a good way and in a good design, right? So this will be my first approach. Let's see if that works. All right, it is now 1.5 days later, and I am still working on the same thing. As you can see here a little bit, I am currently working on getting it as smooth as possible. You can see this because I'm running clocks and I am trying to manipulate very large areas and trying to make sure that these clocks are still running the same way. And then obviously I have the server running and there I'm logging as well, right? But it's oftentimes very nice to see if a clocks works kinda okay-ish still, or if you can see that something is very, very laggy. All right, and then you can see here, I am currently, my test is simply just rotating all of this, right? So we have a very, very large area, as you can see. And my test is basically just rotating and rotating and rotating and rotating and trying to get it better and better. Yeah, let's see. Maybe I finish this today. Alright, while testing I found a little bug with Redstone and Chunkli. This should have been there for quite some time, but most likely this was not important for players until now. For admins it's quite important. If I have a ticking redstone clock like this one and I stack that one in a direction, then it's possible that the redstone gets buggy. You can see here now this redstone is ticking differently than this one. And if I do it now again, and maybe one more time, and one more time, you can see now that somehow the clock is behaving differently. And yeah, I found why that is happening, so I can just live change this fix and we can go back into the game, and if I stack it now again, bam, these bugs are fixed. Perfect. Alright, a couple hours later, it's finally kinda working in the way I wanted to. You can see here I have my little test set up. I have a redstone clock running to see if the server feels laggy. This is different to the server actually being laggy, so this is why I mostly test with this in the end. Then you can see I have my test area here selected. This is currently a 20 by 20 area. I normally do this with a 40 by 40 area, but now for the video I'm gonna reduce it a little bit. Then let's do the first test. And let's see what happens. If I just rotate this, you can see this is pretty quick, right? This took 4 seconds to rotate all of this. And if we look into the console, we can see there are some outputs here. This is how I measure how much time was being used up. And I am currently giving the system a lot of time to do this, right? So I allow it to lag the server basically. So let's try to see if it's actually laggy. Let's rotate this again and look at the redstone clock. And we can not really tell that anything happened there. But we can see a little bit of lag was recorded here in the system, and that lag was then causing a reduction in the speed for a short period of time. Or should have normally, but it didn't in this case. I can see it now because we allow the system to take up to 150 milliseconds, but this lag only lasted for 70 milliseconds. All right, let's reduce the settings. Let's say only 5 milliseconds are allowed, so this is pretty low. And let's redo this test, and this is gonna take 1 or 2 tries probably, because the system needs to first learn about this lesser time it has, and then it's probably going to slow down a little bit. So let's do it once, let's do it twice, and we can see now it recorded a lag here, and because of that it slowed down significantly. Let's rotate one more time. We can see it again recorded a lag. This time this was a smaller lag than the one in the first step here. But in the first time it had way more time in its hand. So now it's reducing the allowance even more, how much it can do per tick. And if we do it once more, we can see now it's taking its time, right? It takes a lot more time to do this. And the whole action is now slowly going through this. And it is no longer as fast as before. And that is pretty much what we want to have. We want to be able to tell the system how much time it's allowed to take and how long this kind of action should take. So you can see this is slowed down significantly. This is obviously too slow, most likely. So I'm gonna opt for something in the middle. And yeah, but this feels nice. We can keep redstone ticking normally. You shouldn't feel any difference while gaming, and you would still be able to rotate whole areas. All right, okay, maybe give you an idea of what this tool should be used for in the end, and still not like the server. I have now selected a 40 times 40 area. So these are 1,600 chunks. So if we just calculate how much data we need to move here, we can say that we have, give me a second here. We could say we have 40 times 40 chunks, and then we have 16 times 16 blocks times 265 blocks in height. This would be the total amount of blocks we are now trying to move to some other place, in theory. In practice, because we do not have this built up to the ceiling, we could say maybe this is a little bit less, right? So up to maybe height of 60 or something. We could say that instead of times 265, we only do times 70 or something, then we are around about at 30 million blocks. And if we move this, or if we rotate this, we can see the system here now automatically slowing down, raising up again, slowing down again, raising up again, and so on. This is what we want to happen. And then after it finishes, it will start moving these chunks. So now it's finished creating a backup, and now it's going to start moving these from this side here, and we should see the changes here right there. And you can see the system slowly going through the area. And I'm gonna move the last bit here, and then we can see how fast it moved all of this area. So now it's finished. So this is 36 seconds for about 30 million blocks. So this is quite nice. And let's quickly look into the log. We can see, let's see, there are some minor lags here. I allowed it to take a lot of time from the tick, so there are some minor lags here, but mostly as a player, you wouldn't be able to notice these. And then we have a small error here. This one is expected currently, so this one doesn't matter. And yeah, that's it. So there's only pretty much one lag we want to try to avoid, and this is probably why I'm going to slow down the system a little bit more on the running server. But for an admin action in this size, this is very, very good.